Hello everyone. In my last video I kicked off the year explaining the steps that are needed if we are to transition into an access-abundant economy and a sustainable society that values community, freedom and well-being. One of the things I talked about in that last installment was the general localization of economies. In the context of the transition, as we move away from centralized, globalized economies, we will likely see a shift towards more distributed, democratic modes of production, with things produced and consumed closer to home. In a localized, distributed economy, goods don't need to travel nearly as far as they do today. People of the community are much more likely to have more say in how things are run, and said people are more likely to benefit from projects, initiatives, and enterprises that happen inside their community rather than halfway across the world. A significant reduction in global freight would mean less work and less emissions. It would be a huge efficiency gain, and localization in multiple respects puts power in the hands of the people. I've talked about localization before on my channel, and you can go check that video out in my Fundamentals of RBE's playlist, although I've resigned the use of RBE as a term. I think those videos are still worth watching, and a link to said playlist will be provided in a end screen at the end of this video. While that video talked about the benefits of localization, this video will deal more with the practicalities of the matter, and we'll examine along the way some technologies that could help us localize our production, distribution, etc. in a pretty big way. In fact, I think it's possible that we can take many current industrial processes and scale them down to the local level, from agriculture to fabrication to medicines to textiles and more. This is something I term hyperminiaturisation, and it's the main topic of this video. As I articulated in my previous video, there are many industries such as banking and finance, the stock market, etc. that we could do without. However, there are many other industries that are the bedrock of modern life, and without them all, we'd be cast back into the Middle Ages, at best. Every modern society needs food, shelter, medication, healthcare, education, energy, heating, communications, etc. in order to function properly. And all of these require resources, materials, technologies, etc. that need to be produced somewhere. One might think that it's simply impossible to provide all or most basic needs and reasonable wants at a local scale for the local population. However, if we make certain community design choices and we utilize certain technologies and techniques, we can make localization a lot more practical. Let's consider food as our first example. Modern societies consistently use large-scale monoculture. This is a form of horizontal agriculture where lots of land is used to grow one crop and not much else. We do this because for most of human history this was the way to produce a large amount of food. Because monoculture uses a vast amount of land, it isn't really feasible at a local level. In fact, its land inefficiency, along with its water inefficiency, are both big drawbacks of traditional monoculture. What can we do about this? Well, if you've been a watcher of my channel for a while now, you'll know that I'm an advocate of vertical farming, particularly if redirected sunlight is used instead of artificial lighting, as that means natural light is being used rather than energy being spent to artificially light crops. And this gets around vertical farming's biggest pitfall, which is its energy use. But for a local community, how much vertical farm do we actually need? While we can't make too many assumptions, people's diet varies from region to region, generally speaking. We can make estimations based on how much land per person is required to feed them. According to the website Place Call Home, the average person needs around 5 acres of land to adequately sustain themselves. This obviously assumes traditional horizontal agriculture. This also assumes a plant-based diet, something which I think will become much more common in the future. Anyway, we have our number, 5 acres to an average adult, or equivalent. This is actually pretty easy to densify into a lesser footprint. Say you have a 10-story mid-rise building dedicated to vertical farming. Each floor is in between 3 and 4 meters in height. With the exception of things like corn and tree fruits, most things could be grown in racking, with light and water and nutrients supplied to them. Now let's assume that in this building, each floor has a surface area equivalent to about half an acre. That's about 45 meters each way, and this surface area is about equivalent to somewhere in between a quarter and a third of a football pitch. Now let's say we dedicate half of the space, the floor space of each floor to vertical farm racks, and we dedicate the other half to gangways. So that's a quarter of an acre of usable space per floor. That seems kind of inefficient. Let's say the racks that we're going to be using took up 75% of space per floor rather than 50%, and we allocated, say, now a quarter of our space to gangways. That would leave us with 0.375 acres per floor, which is a bit more favourable, and I actually think that would be more realistic in real life. Now say we make each of these racks 40 centimeters tall. This would give enough headspace for a lot of crops, but would also allow us to have 10 stacks of crops per floor. Thus, in this vertical farm setup, we have 3.75 acre equivalents per floor. The resulting 37.5 acre equivalents of the entire mid-rise building would be able to feed 7.5 people. So probably in real terms that means that a single mid-rise vertical farm that's 10 stories would be able to feed around 7 adults and a child. If you opt instead for 12 stories instead of 10, you go a little bit higher, you'll be able to feed 9 adults with a single mid-rise vertical farm, at least one with a half-acre floor space per floor. So a downside to localising food production in this way may be that, okay, you need to build all of these vertical farm buildings. However, each building only consumes half an acre, and you're feeding 9 people with that half acre, at least with the calculations I just made. What this translates to is roughly 111 of these buildings to feed 1,000 people. That sounds quite a lot, but it's actually only around 55 acres per 1,000 people. It's better to express this densifying of agriculture with vertical farming in terms of area rather than the number of buildings, primarily because it doesn't have to be so that a vertical farm is always a 12-story mid-rise building just standing on its own. Food production and agriculture in general could very likely be more integrated into other parts of a town or city system, and even someone's home, and this could densify the availability and growing of food even further. Something I've actually seen people do online is attempt to integrate food cultivation into the local environment, such as simply planting a fruit tree, for example, that's free for anyone to take from. But naturally there are many other ways this could be done, and those calculations that I just made aren't always going to be accurate for every scenario. But nevertheless, with those numbers in mind, if you have a population of, say, 10,000, and these people live in an area of about 2,500 acres, that means that about a fifth of the land of that community would need to be dedicated to vertical agriculture, which isn't too unreasonable, all things considered. As I said before, this would vary massively in terms of people's diets, what crops are needed over others, and so on and so forth. Different types of agriculture and the way people set things up will likely vary a lot too. But localization of agriculture via vertical farming and other methods such as food forests is definitely a viable option. We've talked a lot about growing food and agriculture and stuff. Now let's talk about some other stuff that we can localize or hyperminiaturize, if you will. There are various techniques and technologies that make manufacturing at the local level possible, from tools to trainers, from furniture to bespoke fabricated parts, from bikes and other forms of microtransit to wind turbines, and a whole host of other things. 50 years ago, this would have been impossible. It would have been unthinkable to imagine someone manufacturing a quality good inside their own home. Yet today, we have technologies such as 3D printing and CNC machining and so forth that make small-scale batch production of high-quality goods possible. 3D printing, for example, has come a long way in the past 10 years, and even though it still has a long way to go in terms of user-friendliness, it is more accessible than ever before. And there's even devices on the market that combine 3D printing with laser engraving and CNC machining all in one package, enabling users to create a wider variety of products from one device. And this kind of hyperminiaturization, in this case micro-manufacturing, allows a paradigm shift in how we produce things. You see, today we often rely on mass production to produce consumer goods. This is often done in a centralized manner, and it makes it difficult to predict demand on a global scale. And this creates tons of needless waste through overproduction. And let's not forget the ecological impacts of global freight. So what's the alternative? Well, with these micro-manufacturing technologies, what that enables is something known as production on demand. This is where you have a design for something. It could be a model on the computer screen, for example, and then you could have that printed or machined or what have you on demand, either at home or a local workshop, or whatever the arrangement is in the local community. A local co-op could even set up a service where they deliver goods to you based on what you order on their website, much like how e-commerce websites work today. Except rather than selecting the item from their massive stockpile of goods, they instead make it right there and then and send it to you. It's made to order. This kind of production on demand eliminates waste and absolves the need for things like warehouses, which would take up a lot of space in a local town or city system. And localized micro-manufacturing in general puts power in the hands of local producers, especially if the resources and information that's needed to create products like software, designs, etc. are completely open source. Of course, 3D printers, CNC machines, laser engravers, etc. can only make things out of plastic, wood, and metal. But what about more complex goods, such as semiconductors, the foundation of modern technology? Well, if you're familiar with how PCB fabrication works, which is another thing that can be scaled down quite easily, the manufacturing of semiconductors has similar motions to it. You basically grow an oxide layer onto a wafer. You then do something called photolithography, which is basically applying a coating to the wafer and basically blasting it with UV light, using either masks or maskless techniques in order to create a pattern. Once the polymer has set, the regions of oxide that are left exposed can be etched away, and you are left with a silicon pattern, which can then undergo something called doping, which is where you introduce impurities into the wafer that make it more conductive in certain areas. Now this sounds like something that could only be done in some huge facility somewhere with all sorts of complex equipment. However, that has been proven not to be the case. There are a couple of people on the internet and on YouTube who have successfully created integrated devices in their own home. The YouTuber Sam Zaloof has created his own audio amplifier, and he's experimented with some other stuff like photovoltaics as well. Yes, this is nowhere near something like a modern CPU you find in your desktop, and small-scale chip fabrication is still quite a bleeding edge thing, since until recently it's been largely restricted to large industry. However, with more research and breakthroughs, I think this could be improved dramatically, especially if we are able to, and I think this is quite a viable idea, create a kind of desktop device that does all of the steps involved in the semiconductor fabrication process and leaves users with a fully home or locally made chip. And this is something in the future that I want to research with Adenia. And this leads me to talking about a big way that we could really push hyperminiaturisation forward. And this kind of follows in the spirit of open source ecology, something you should check out. And this idea is to create a selection of machines that can carry out an industrial process at a small scale. A 3D printer is virtually a box that creates plastic parts. The semiconductor machine I described just now is a box that fabricates semiconductors at a small scale. And I think that principle could be applied to many other things to create a variety of devices that serve their own purpose. And I think this would all mesh really well with the idea of production on demand. But how do we power all of this stuff? How do we power all of this localized manufacturing, this localized agriculture, and so on and so forth? The answer is distributed energy, most often in the form of renewables. Now, when a lot of people talk about renewables, they often question which renewable source is better than the other. And that's the wrong way to think about it. You see, renewables are best used in a mix. That is, instead of just using wind or just using solar or just using geothermal or what have you, you use a mix of those so that if one source of energy stops producing for whatever reason, you can use the other sources of energy as a backup. For example, if you have a combination of solar and wind, it may be sunny but there's not much wind, so you would use solar. However, on a windy day that's quite cloudy where solar isn't as optimal, you could rely on the wind more. And this is sort of a way, well, this is one way of dealing with the intermittency issue. Now, how would this be implemented? Well, rooftop solar is the obvious solution for solar panels. However, there are other techniques that could be used, such as solar thermal, which has many diverse implementations. When we think about the traditional wind turbine, it's known as a HAWT, or a horizontal axis wind turbine. Now, that's very good if you have a lot of space and you have high altitude and you place a wind turbine there, and it will be very, very efficient. However, in an urban local setting where you have low altitude and wind isn't always consistent, horizontal turbines fall out of favour. You see, in urban environments, wind is quite intermittent, it's quite gusty, and it comes from all different directions. Here, a vertical axis wind turbine would be more beneficial. They also don't kill birds. But also, rather than having huge turbines scattered all over the place, in a localised, hyperminiaturised setting, people are more likely to rely on microgeneration, and at small scales, vertical axis wind turbines prevail. In fact, if you combine a few smaller vertical axis wind turbines in a little cluster, you get something called a wind catcher, which is more efficient than having a single large wind turbine. And other forms of wind catchers have actually been researched by people in Norway. Having the energy supply distributed like this, in a decentralised fashion, gives individuals and communities control over their supply, as opposed to large centralised entities like energy companies. And doing it this way also makes communities much more resistant to things like power cuts, because in a centralised system, if the local power plant goes down, everyone in the town or local area is affected. Whereas in a distributed decentralised system, if one person can't get power to their home, that doesn't affect the entire community. Thus, with localised, distributed, decentralised forms of energy, you have a lot more resiliency. Now, what about the things that we can't localise as easily? I mean, we can localise a lot. We can create hyperminiaturised solutions for agriculture, manufacturing of hardware, energy, even the small-scale production of things like medicine. But there are some cases where this is impractical. What about chemical plants, for example, that use dangerous yet necessary chemicals to manufacture things like medicine precursors, polymers, and so on? A solution to this could be that multiple communities collectively control these types of facilities, and each community that's part of that agreement has access to the outputs of said facilities. And if possible, people in each of the communities could research different ways, safer ways, to manufacture these goods at a more local level. This same principle could be followed when it comes to things like nuclear power plants, where it would be impractical for each community to have one, and where the nuclear plant could supply enough energy to multiple communities. Although there have been some attempts to miniaturize nuclear power, I don't think it will catch on, honestly. As safe as nuclear power can be, I don't think we want regular people handling radioactive isotopes too much, or worse still, dealing with nuclear waste. Not to mention that such isotopes, even fertile fuels like thorium, are a finite resource, which actually is a good segue into my next point, which is, if most things are localized, how would people and communities get their resources, specifically precious metals? In modern society, we rely on many rare earth metals to facilitate our standard of living. They have countless applications, from batteries to motors to catalysts, certain types of medicines, and so much more. Yet they are only found in certain areas of the world. The market has dealt with this through international trade of newly extracted resources. Exchange of needed resources between different regions of the world could still exist in a post-scarcity setting. However, it would be much less needed due to thorough implementation of circular economies. There are so many precious resources just lying there in landfills, and it would be a good idea to recycle them more rather than extract new resources overseas. Recycling has the problem of being energy intensive, but I doubt it's more energy intensive than the refining process of fresh material. Plus, communities can just upscale their energy supply if they need it. Silicon is the most abundant metal on Earth, and dopants like boron and phosphorus aren't too rare either, so you're not really depleting the Earth's resources by just building more solar panels. And if a community wants to grow crops that fare well in its local environment, and also wants to expand its solar capability, it can do something called agrivoltaics, which is integrating a kind of horizontal agriculture into a solar array. And the advantage of this is that it makes more efficient use of land. You're both generating energy and growing food on the same plot. Now, back to recycling and the circular economy. It is not too difficult for people on a local scale to recycle things like paper, plastics, metals, glass, and other basic materials. It's even possible, given enough skill and in a safe environment, for people to DIY recycle more complex goods like batteries and PCBs. This recycling aids in localization because it removes some of the need to rely on outside sources for raw materials, and doing this at scale in a circular economy increases the local availability and thus abundance of resources, and also slows the depletion of Earth's natural resources. Now, where would all of this recycling and, not to mention other forms of production, take place in a local setting? I'll talk about this in another video that's more appropriate for this topic, but in essence, if someone is unable to produce something at home for whatever reason, then communities should have facilities that allow local production to happen. On an informal scale, this could mean something like communal workshops or kitchens. However, on a wider community scale, this could mean something like having an area dedicated to commons cooperatives who engage in local industry and provision of goods and services. Think about a shopping centre today, except everything is free and held in common, at least in an access-abundant context. Now, there's probably a couple of other things I could have covered in this video, but I'm going to end it there. Hopefully I have explained well enough what hyperminiaturisation is, and how it can be implemented to localise production, and how we can bring production back into the hands of regular people and communities. For now, I will stop rambling and actually get on with a couple of projects, but my next video like this will be surrounding housing and how we can build the communities of the future. For now though, I hope you've enjoyed this one and hope you have found it informative. You can support me by liking this video, sharing it, and dropping me a sub if you're so inclined. Also, why not drop a comment and let me know what you think. Anyway, that's it for today. Thank you all, and I will see you in the next one. Take care, bye for now.